we need to take the ln of this equation, which means ln of x power n y squared equal to ln of the constant c. The variables x and y satisfy the equation x power n y squared equals c, where n and c are constant. The graph of ln y against ln x is a straight line passing through the point 0.31, 1.21, and 1.06 and 0.91. As shown in the diagram, find the value of n and find the value of c correct to 2 decimal places. We're given here a graph of ln x and ln y. The two given quantities on the axis are ln x and ln y, not x and y. So the relationship between ln y and ln x is a linear relationship, and therefore we can represent it as follows. Ln y is a constant k or something, and then times ln x, and plus another constant d. The point is that we need to understand the problem given here, the two quantities ln y and ln x. It's about the way of thinking. It is similar to a normal linear relationship that we usually have, y equal mx plus c, where m is the gradient of the line and c is the y-intercept. In this relationship, k will be the gradient also, and it will be a negative gradient because the line goes down, decreasing like this. It's not going up, okay, but it's decreasing, and therefore the gradient k here is negative, and d here is the y-intercept, which is this point, the intersection between the line and the vertical axis. So to have this relationship, we start from this given equation. We need to take the ln of this equation, which means ln of x power n y squared equal to ln of the constant c. The next step, we will use the property of a ln function, which is ln of x power n will be equal to n. We bring the power down, times ln x. And the second property, ln of a times b, is equal to the sum of ln a and ln b. So here, ln of x power n times y squared will be equal to ln of x power n, and then plus ln of y squared. It's equal to the ln c. Then the next step, using the next properties here, ln of x power n will be equal to n times ln x, and then 2 here, ln of y equal to ln c. And we want to get to this following relationship between ln y and ln x. So we just need to arrange this equation a little bit. So we'll have the ln of y will be equal to 1/2 of ln c minus n over 2. We divide 2 here, okay? Ln x minus n over 2 ln x and plus 1/2 of ln c. So now this is the relationship between ln y and ln x, which is a linear relationship. We need to find the value of n and the value of c. So the value minus n over 2 here is the gradient, and we can find that gradient by using the given values, the 2 points on the graph, 0.31, 1.21, and 1.06 and 0.91. The gradient is the rise over the run, which is 0.91 here, minus the other y value, 1.21, and then we divide the change in x, which is 1.06 minus 0.31, and of course this gradient will be a negative value. The gradient is minus 0.4, and that thing minus 0.4 is equal to minus of n over 2. So n is 2 times of 0.4, meaning 0.8. So now we have found the value of n. The last thing, to find the constant c, we can plug the value of 1 point. We can choose any of these 2 points and plug into this equation. Plug that value into this equation, okay? And then we can solve for the value c. I will plug the value x to be ln x to be 0.31 here. So ln x here is 0.31, and then times minus of n over 2, which is minus 0.8 over 2, and then plus ln c. We are finding c, okay, finding c. And ln y is this value, 1.21. 1.21 is ln y. So lastly, solve the equation, we can find the value c to be 14.41.